All right, today in geometry, we're looking at chapter 6, section 6.1, which covers ratios, proportions, and geometric mean. So we're going to start out with some vocabulary. So first, what is a ratio? A ratio is a comparison of numbers A and B using division, where B cannot equal 0 because we cannot divide by 0 in math. So it is usually expressed in simplest form and can be expressed as. So there are three different ways that we can express a ratio. The first one, it can look like A over B, looks like a divided. And it could say A and then our colons to B, or we could write out A to B. They're all read the same way, A to B. An extended ratio are ratios that can be used to compare three or more quantities. So this is where we would just have like A, B, and C. So let's see, we could say A to B to C, or if we had 4, we could say A to B to C to D. So that would be an extended ratio. Okay. All right, so we're going to look at our first example. Express the ratio of sides of the triangle in simplest form. So they give us triangle JKL. They show us that J to K is 12 inches, K to L is 16 inches, and J to L is 20 inches. And then they give us the ratio, segment JK to segment KL to segment JL. So if I do segment JK, it's 12. To segment KL is 16. To segment JL, 20. But we're not going to leave our ratio like this because we always put it in simplest form. So we look at 12, 16, and 20. What's the biggest number they all have in common? I can take a 4 out of everything. So if I take a 4 out of 3, a 4 out of 12, I'm left with 3. 4 out of 16 leaves us with 4. 4 out of 20 leaves us with 5. So our ratio, because they gave me units over here, is going to be 3 inches, 4 inches, or 5 inches. There's the ratio of the sides of triangle JKL in simplest form. Next, let's talk about equivalent ratios. So equivalent ratios are ratios that have the same simplified form, because remember, equivalent means equal. So this example says express the ratio of width and height of the rectangle in simplest form. So the width of the rectangle is 30 feet. The height of the rectangle is 15 feet. It's important to note that they are both in the same units. So we can go ahead and simplify this. So 30 goes into 15, right? They both have 15 in common, so 15 goes in 30 twice over 1. So that's 2 feet to 1 foot. Or I could write this as 2 foot to 1 foot this way. So there's the ratio of the width and the height of the rectangle. Remember that if we have a ratio, we must have the two numbers. So that 15 cannot just go away on the bottom. We have to put that 1. So we're going to simplify these. So the first one says 35 meters to 7 meters. So I can write this 35 meters over 7 meters. Again, what's the biggest thing that they have in common? I can take 7 out of both of them, so that becomes 5 to 1. So we're going to write this out, 5 meters to 1 meter. Or I could write it as, we're going to write the 3 different ways we could do, 5 meter to 1 meter. Or we could say 5 meters, then write out the word to 1 meter. So B, 45 to 63. So 45 and 63, we're looking at what's the biggest number that they both have in common. So 45 over 63. Then 9 will go into both of them. So 9 goes into 45 5 times. 9 goes into 63 7 times. So I could say 5 to 7. I could say 5 over 7. Or I could write out 5 to 7. No units were involved in this one, so we don't have to worry about that. But the last one, 5 feet to 20 inches. I notice they're not the same units. I must have the same units, okay? So must have the same units. So the very first thing that we want to do here is put them in the same units. So I'm going to take 5 feet over 20 inches. I know that there are 12 inches in 1 foot. Okay. So then that's going to get me my inches. Okay. So let's see, on top I would do 5 times 12, so that gives me 60 over 20 times 1, 20. So that becomes 3 to 1. So I could say this is 3 inches to 1 inch. I could say 3 inches over 1 inch, or 3 inches to 1 inch. We go with our smaller units. Okay, so we turned the feet into inches. We always want to keep our smaller units there. All right, let's go to the back of this page. So it says write the ratio expressing the slope of each line segment. So let's recall what our formula is for slope. So slope is y2 minus y1 over x2 minus x1. So part A wants the slope of A to B. So let's see, A, this is the point for -4 comma 5. B, this is the point 3 comma 6. So the slope of A to B is equal to 6 minus 5 over 3 minus -4. So simplify this, 6 minus 5 gets us 1. 3 minus -4 turns to 3 plus 4, 7. So there's our ratio, 1 to 7. We could put 1 unit to 7 units. Slope of C to D, the ratio of that. So C, this is at -4, 2. D is at 0, -6. So here our slope, -6 minus 2 over 0 minus -4. -6 minus 2 becomes -8. 0 minus -4 turns to +4. That reduces to -2 over 1. Remember that we have to leave that 1 alone. Anytime we're doing a ratio, we will have 2 numbers. So I can say -2 units over 1 unit. There's our ratio. And finally, we're going to look at the slope of E to F. So E, this is the point 3, -4. And F is the point 6, 4. So here our slope, -4 minus 4 over 3 minus 6. -4 minus 4 turns to -8. 3 minus 6 turns to -3. Negative and negative turns to positive. So I've got 8 units over 3 units. Simplify. All right, now we're going to talk about proportions. We've seen proportions before. So proportion is an equation stating that 2 ratios are equal. So here I have A over B is equal to C over D. Some more vocabulary word, extremes. They are the first and last positions in the proportion. So in this example, A and D would be the extremes. Then we have means. Means are the 2 middle positions in the proportion. So B and C would be considered the mean here. So we're just going to solve each proportion. Remember, we still solve the proportions the exact same way. So if you have a proportion, you simply cross multiply. So -16 times x equals 8 times 11. So then we get -16x equals 88. We're trying to solve, so we want to get x by itself. So divide by -16. So then I get x is equal to -88 over 16, but we always want to simplify. So 88 and 16, they both have an 8 in common. So x is equal to -11 over 2. There's our answer. We could always plug it back in to check. Number 2, -6 over 9 equals 8 over 2y plus 7. So -6 times 2y plus 7, that whole thing in parentheses, equals 8 times 9. So here we want to distribute our -6, so we get -12y minus 42 equals 72. We're trying to get y by itself, so we're going to add 42 to both sides, and we get -12y equals 114 divided by negative 12. So y equals negative 114 divided by 12. But again, we want to go ahead and look at simplifying that. The biggest number they both have in common is a 6. So negative 114 divided by 6 gives us negative 19. 12 divided by 6 gives us 2. So y equals negative 19 halves. Number 3, we have n plus 4 over 3 trying to get this equals 5n over 6. So we're going to cross multiply, and I get 6 times n plus 4 equals 3 times 5n. So distribute our 6, and we get 6n plus 24 equals 15n. We want to get all of our n's on the same side. So if I move my 6n over, I get 24 equals 9n. And divide, so 24 over 9 equals n. They both have a 3 in common, so this will reduce to n equals 8/3. Now let's look at number 4. Z plus 1 over 11 equals z minus 2 over 15. Again, cross multiply, so 15 times z plus 1 equals 11 times z minus 2. So on this one, we need to distribute on both sides. So we get 15z plus 15 equals 11z minus 22. Get all of our z's on the same side. So I'm going to subtract 11z over. And then I'm going to get 4z plus 15 equals negative 22. Subtract 15 from both sides, and I get 4z equals negative 37. And divide, so I get z equals negative 37 over 4. They don't have anything in common, so that would be our final answer. All right, next page. We want to talk about geometric mean. So the geometric mean of two positive numbers, a and b, is the positive number x that satisfies the proportion a over x equals x over b, so that x squared equals a times b, and x is equal to the square root of AB. Okay? So find the geometric mean, 24 and 48. So I can set this up, 24 over x equals x over 48. Cross multiply, x times x gets me, or I can write that out, x times x equals 24 times 48. X times x gets me x squared. 24 times 48 gets me 1,152. Need to get x squared to just be x, so I take the square root of both sides. So here I'm going to do the factor tree. So I know that this came from 24 and 48. 48 will break down to 24 times 2. I could break the 24 down, but remember when we're doing factor tree on the square root, I'm only looking for 2 that are the same. So I've already got two 24s. So here I've got x is equal to 24 comes out, square root of 2, the 2 gets left behind. So the geometric mean between 24 and 48 is 24 square roots of 2. Let's do the second one. Find the geometric mean between 12 and 27. So again, I'm going to set it up. 12 over x equals x over 27. So x times x equals 12 times 27. So then we get x squared equals 324. Take the square root of both sides. I need to do the factor tree. I know that this came from 12 and 27. 12 will break down to 3 and 4. 4 breaks down to 2 and 2. I have a pair of 2's. 27 breaks down to 3 and 9. 9 breaks down to 3 and 3. I have a pair of 3's and another pair of 3's. So this was a perfect square. So x equals, so I have 3 times 2 is 6. 6 times 3, 18. So here, the geometric mean is 18. The last example of geometric mean, the numbers 18 and 54. So again, 18 over x equals x over 54. So x times x equals 18 times 54. So I get x squared equals 972. Take the square root of both sides. Do factor tree 18 and 54. I know 54 will break down to 18 and 3. Again, I'm not going to break my 18s down because I already have a pair. So x equals 18 comes out. The 3 got left behind. 18 square roots of 3. There's my geometric mean. All right, one more example we're going to look at. The ratio of side lengths of a triangle is 3 to 4 to 5. The perimeter of the triangle is 72 centimeters. What is the length of the longest side of the triangle? So I don't know what kind of triangle this is, so I'm just going to draw a triangle. This is 3, so I'm going to say 3x because it's a ratio. So I know that it got simplified down, right? Possibly. So 3x, 4x, and 5x. My perimeter means add up all of my sides. So if I add up all of these, I get 3x plus 4x plus 5x. The perimeter, they tell me, was equal to 72. So that's how I'm going to set this up. So now I need to find out what is x. So if I add these, okay, 4 plus 3 is 7, 7 plus 5, I get 12x equals 72. Divide, so 72 divided by 12, x is equal to 6. Remember, that's not my answer because they asked me what's the longest side. The longest side had the ratio of 5x. So the longest side, 5 times 6, is equal to 30. So my longest side, and I have to have units, is 30 centimeters. All right, so that is lesson 6.1. The vocabulary for chapter 6 has been posted in the chapter 6 module on Canvas. Your homework tonight is the 6.1 worksheet, doing everything that we just did here. Just make sure that you simplify all of your ratios and that you have the two numbers at least, right? If you end up with a 1, you have to write the 1 in your ratio. You cannot just leave it as 2. You would have to write as the 2 over 1, etc. All right, that's 6.1.